So, good day once again. So, we are now under the topic about Heaviside functions. So, particularly, we will be finding the Laplace transform of Heaviside functions at the end of this given presentation. So when we say Heaviside function, so this is a unit step function. So it has only two values, so which is defined by this function. The mu sub c of t is equals to 0. So given that t is less than c, but if it is greater than or equal to c, so that would make it equal to 1. So there are only two discrete values for a Heaviside function. It's either a 0 or a 1. It is 0 if it is less than a c, and then it is equal to 1 if it is greater than or equal to c. So c here is the unit step, so where it will be shifted to another value from 0 up to 1. So that is for the Heaviside function. So by the way, Heaviside function so could be multiplied with another function. So for us to have a different value, okay, so for different period of time. So for Heaviside function, or what we call as the unit step function, so it uses different notation. So the one that we used before is the u sub c of t. Okay, so t would be the time, and then c is where it will be shifted. Okay, and then other notation uses u t minus c. So the other uses h, so for Heaviside, so t minus c. So whichever would be the notation that they are using, so we are referring to we are still referring to Heaviside functions. This time, so how do we find the Laplace transform of a Heaviside function? The Laplace transform of the Heaviside function, as long as the function that is multiplied is properly shifted. So that means if it is shifted to c, so therefore the function should have a t minus c. Okay, so c here is if it is shifted to c, so therefore we should have a t minus c there. So there are cases that it is not properly shifted, so therefore we have to do something on our given function so to shift it, okay, on a correct value. So once it is shifted on a correct value, then the Laplace transform of the unit step function, so multiplied it with any function, so that would be equal to e raised to negative cs, so times the Laplace transform of the unshifted function. Okay, so that is the Laplace transformation for Heaviside. Okay, so let's find the Laplace transform of f of t is equals to 5 times a unit step function, so which is shifted to 8, and then plus 3t minus 2 squared, and then u sub 2 of t. So unit step shifted to 2. So to resolve this one, so let me rewrite it first. So f of t so would be 5 u sub 8 of t, and then plus 3 t minus 2 squared u sub 2 of t. So from here, our unit step is 8. Okay, so our unit step is shifted to 8, and then it's just multiplied to a constant, so therefore that is properly shifted. However, so we have plus 3t minus 2 squared. Okay, so this one we have a unit step again, so shifted to 2, and then our function f of t has a t minus 2, so which is shifted to 2 as well. So therefore, so from here, so we can use our formula, so that the Laplace transform of u sub c of t is multiplied it with t or f of t minus c. So its Laplace transform so it would be equal to e raised to negative cs, and then the Laplace transform of the given function. So in the first term, we just have our 5u sub 8 of t. So our unit step is u sub 8 of t. And then our f of t then, so would just be 5. Okay. And then in the second term, so we have 3t minus 2 squared u sub 2 of t. Our f of t minus c there, so that is the 3t minus 2 squared. Okay, so it would appear here that for our second term, so our f of t, okay, is actually equal to 3t squared, and our f of t minus 2, so where it is shifted, so that would be 3t minus 2 squared. So in short, the Laplace transform of this, the f of s, so would be equivalent to e raised to negative cs. So e, then negative c, that would be 8. Okay, so for our first term, so negative 8s. And then the Laplace transform of our f of t, in that case, that would be 5. So that is 5 all over s. And then plus e raised to negative 2s. Then the Laplace transform of 3t squared. Okay, so which is our f of t here. That would be 3 multiplied it with t squared, so 2 factorial, so divide it with s raised to 2 plus 1, so we have 3. Or our f of s then, so would be equivalent to 5 e raised to negative 8s all over s, and then plus 3 times 2 will have 6 e raised to negative 2s all over s cubed. Or our f of s then, so would be equivalent to s cubed, and I'll have 5 s squared e raised to negative 8s, so plus 6 e raised to negative 2s. So that comprises our final answer. Okay, so for the Heaviside function, so we're in the unit step, or the involved functions are properly shifted. Okay, so for our unit step, so our final answer is 5 over s e raised to negative 8s, so plus 6 all over s cubed e raised to negative 2s. So giving our final answer. So let's have another example. So this time around, we have f of t, so which is t squared u sub 4 of t, then plus cosine t u sub 2 of t. Okay, so we have two Heaviside functions. So one, or the unit step function, is multiplied with an algebraic t squared. So the other one is multiplied with cosine. So we are to find the Laplace transform of this one. The only problem, so for our first term, our unit function is shifted to 4. However, our t is not. Okay, so that is why we have to properly shift it. To do that, So f of t then, so would be equivalent to, so we're going to shift it to 4. So if we subtract 4, so we'll just have plus 4 as well there. Okay, so that it would be properly shifted. And then we have u sub 4 of t. And similarly, for our second term, so our unit function is shifted to 2. However, our cosine is not. So what we will be doing there, so we'll have cosine, so t minus 2 plus 2. And then u sub 2 of t. So now this is already properly shifted. But how do we find the Laplace transform of this? So let's try to expand. So f of t here, so would become, so the expansion of t minus 4 plus 4 in such a way that we will retain the t minus 4. So because that is the shift that we need. So in this case, so this would become t minus 4 squared. Okay, so t minus 4 squared. And then plus 2 times t minus 4. Then multiplied it with 4. So this is just a binomial expansion. And then the last one, so we'll just have plus 4 squared, so which is 16. So all of this is multiplied with our unit step function u sub 4 of t. And then for cosine, so remember that so for cosine a plus b, so cosine a plus b is the same as cosine a cosine b minus sine a sine b. So we're in a here is t minus 2 and then b is 2. So doing so, so given that a is, okay, so this one is our a and then 2 becomes our b. So therefore it would become plus cosine, okay, so so cosine a, so cosine t minus 2 and cosine b, so which is cosine 2, and minus sine a t minus 2 cosine 2 and then u sub 2 of t. So in here, it's already properly shifted. So we'll have a t minus 2 and then we just have a constant cosine 2 and a, this one should be a sine. So sine 2. So from here, so we could distribute. So f of t then, so would become, so we just have the t minus 4 squared, then u sub 4 of t, then plus 8 t minus 4 u sub 4 of t, then plus 16 u sub 4 of t, then plus I'll start with cosine 2. So cosine 2, then cosine t minus 2 u sub 2 of t, and then minus sine 2 sine t minus 2 u sub 2 of t. So therefore, we can now write we can now find the Laplace transform of the given Heaviside function. So t minus 4 squared, so it's just the same as t squared. Okay, so we just have e raised to negative 4t, e raised to negative 4t, and then t squared, so we'll have n factorial, so we have 2 over s raised to 3. And then we'll have plus 8 e raised to negative 4t, the Laplace transform of t, so would just be 1 over s squared. Then lastly, so we'll have plus 16, then the e raised to negative 40. Sorry, 16 should be 16 all over s. And then plus for our cosine, so this is the same as, so for cosine, so we'll just have cosine 2, then multiplied it with s all over s squared. Okay, so it's just t, so cosine t, so plus 1. And then I'll have the e raised to negative 2, sorry, it should be negative 2 4s, negative 2s. Then I'll have a negative sine sine 2, and then I have 1 over s squared plus 1, then e raised to negative 2s. So if we want to simplify this, so we could just have f of s is equals to 2s cubed e raised to negative 4s plus 8 over s squared e raised to negative 4s, then plus 16 all over s e raised to negative 4s. And then in here, so we could combine so we could have the s cosine 2 all over s squared plus 1 e raised to negative 2s, and then minus sine 2 over s squared plus 1 e raised to negative 2s. So to simplify this further, so we could have, or we could combine our denominator. So we'll have s cubed here, and then 2 plus 8s, then plus 16s squared. So everything is multiplied it with e raised to negative 4s. Similarly, so we could have plus s squared plus 1, and then I'll have an s cosine of 2 minus sine of 2. So everything is multiplied with e raised to negative 2s. And that's it. So that would be the Laplace transform of the given Heaviside function. Good day. Thank you.